All right, good morning, good afternoon, good evening. I'm Mr. Atterbury, and let's go over how to solve two-step equations, okay? So this is going to be solving two-step equations. All right, so what's so special about two-step equations? Why do they call them two-step equations? Just how do you do it, okay? You've probably seen it before, but this is just some nice review to kind of get you going to the school year. Let's take a look at let me kind of show you. Let's do some light review of PEMDAS, the order of operations, because it's going to kind of come in handy when we do this, okay? So remember the order of operations, you did parentheses, then exponents, and then multiplication, division, and then addition, subtraction. Like these things were kind of their own little things that you would do in a special order to take a bunch of numbers and then make it down so it was like one number left. So you had like you simplified something, right? That's what PEMDAS is. It's what the order of operations does. It says you got a bunch of stuff you're doing, adding, subtracting, multiplying, dividing. You got parentheses, you got exponents, you got a bunch of things you're doing, or just even a few things you're doing. But there's a special way to do it, right? Well, when you're solving two-step equations, the best way I like to think about it is do this whole thing, or particularly this addition, subtraction, multiplication, division stuff, do it backwards. Okay? Do this whole stuff backwards. And I'll show you what I mean by that. So let's take a look at a classic type style two-step equation problem. Okay? So let's say, I'm going to use some of my favorite numbers, okay? Let's say I have 4x plus 6, okay? And let's say that whole thing equals, I don't know, let's call it 18, okay? 4x plus 6 equals 18. And we want to solve for that value. Because this says, if you think about it, okay, if you read it out loud to yourself, this says 4 times some number plus the value of 6, you'll end up at 18. So you do this and then this and then this, okay? It'll equal 18. What is that number? Now you can do guess and check. Plug in 5, plug in 10, plug in 2, 3, 4, 5, whatever. Plug in some different numbers and get to that answer. But the reason why we do stuff like this is so that you have a process, so that maybe it's a lot uglier. 4.1x plus 6.72 equals 18.11. Like it's got some weird numbers to it, and you know your number's probably not going to be a pretty answer. So it's got to be a way to get there, you know? So let me show you how to do this. Think about the opposite of the order of operations because you're trying to undo something. You're trying to like move things around, and so this x is by itself. It's like you're taking like some like headphone cables that are all messed up, or it looks like spaghetti noodles, and you're trying to undo it. So when you undo it, you gotta go backwards. So thinking about backwards, okay, I have 4 times x plus 6. So with order of operations with PEMDAS, you would want to do the multiplication part first. Well, there's nothing to multiply because you don't have a number. So you got to do this backwards solving process. So we're going to actually look at that plus part first. Okay, the opposite. Okay, do this backwards. The plus part first to undo it. Now we're going to undo this. Like the one-step problems, it says plus 6, so we're going to do the minus 6. When I do that, look at that cancels. And now we're left with 4x. 18 minus 6 equals 12. Okay. Now we have 4x equals 12. Since you got 4x equals 12, it looks like a one-step equation, right? We're on that multiplication division type part, okay? It says 4 times a number equals 12, and if you remember one step, you have multiplication, you should do division, all right? So when we do division, we have x equals to the result of 12 divided by 4. 12 divided by 4 equals 3. Okay. So if I was to, let's say I go over this, okay, and I want to review it, what would that look like? Well, instead of putting x, I'm just going to put parentheses. And I'm going to fill that number in here in a moment, okay? So I'm going to check my work. What if, instead of 4 times x, what if it was 4 times 3? Okay? I'm just going to check my work here, okay? I'm just going to check my work to make sure I'm doing it right, okay? 4 times 3 equals 12, plus 6. Does that equal 18? Yes, it does. Okay? So I feel confident that that's the right answer. Let's go over another one, though, okay? Because it can look a little bit more tricky, and I'm going to kind of show you what that would look like. All right. All right, let's call this example number 2. So once again, think about PEMDAS, think about the order of operations, but we're going to work backwards. Okay, so this says some number divided by 5, then take away 7, and now it equals minus 3 or negative 3. How did we get there? Okay, like what number did we start with? So once again, think about unraveling this stuff backwards from PEMDAS. Okay, and we're going to start with the adding and subtracting part of this problem. It says subtracting 7. So to undo that, to get rid of it, you have to do the opposite of subtracting, which is adding. We're going to add 7. What remains? We have x divided by 5 still. That equals a positive 4. Okay, a minus 3 plus 7 is going to equal a positive 4. And now we're going to multiply both sides by 5. Okay, why am I multiplying both sides by 5? I think you already know that answer. Okay, and if you don't, let's review. Okay, some number divided by 5, we can undo that. We can solve that by doing the opposite of dividing by 5, which would be to multiply by 5. And that's how we solve this part of the problem. Okay, when I do that, I get x left over. And then I have 4 times 5, which gives us 20. Okay. Now, let's check our work. I like to check my work. So if I was given some number divided by 5, and then we take away 7, and that equals negative 3, and I got 20 as an answer. I'm trying to check my work. I plug it right back in where the x was, and let's see what I get. 20 divided by 5, well, that equals 4. Then I take away 7. Does that equal negative 3? Well, let's go back over that trick. Keep this the same. Change that to plus. Make that a negative 7 instead of subtracting a positive 7. And then if you think about your trick, right? 4 plus negative 7. Okay, subtract that, keep the sign of the bigger number, you get negative 3. And that was what I had the entire time. So the result's not negative 3, right? The answer itself actually is just x was 20, okay, to make that a true statement. All right, so hopefully some nice, good, light review. We'll keep working through this stuff through the week. Before getting to geometry, I want to make sure your basic algebra skills like solving 1-step and 2-step equations and doing the order of operations, you guys are rock solid on, okay? Before we get into geometry. All right, have a great day. Talk to you later.